Hello everyone. Let's discuss the midterm examination paper of data structures. Now here, this is a 15 marks midterm paper in which we have 5 questions, 6 questions, right? And all of them are compulsory. Along with every question, the marks distribution is given. Now see, let's see the first question. Sort the following elements using bubble sort with steps. So basically what you need to do is, as you can see that here there are 7 elements. So you will be, applying bubble sort on it, and there will be, if their number of elements are n, then the number of passes will be n minus 1. Accordingly, you have to apply 6 passes and you have to sort this elements using bubble sort. Okay. The next question is also discuss the worst case of insertion sort, total number of swaps and comparisons. So this is a different question. So here in this question, you don't need to take the same set of elements. You can simply take your own example, and for worst case the elements have to be arranged in descending order. So you can take 5 4 3 2 1. So n here is 5, number of elements are 5, and for that you will apply insertion sort. Number of passes will be n minus 1. So 5 elements are there, then 4 passes will be required. Then what you have to do is, in all those 4 passes you have to actually count the total number of swaps and comparisons, applying after applying all the passes. Okay. So this is a very this is a very important question as far as its explanation is required. Okay, so you need to explain it thoroughly in detail without writing any theoretical things. You have to just explain the logical part of it. Now coming to the second question, here you are given in order and pre or post order, right? And you have to construct the binary tree from the in order and post order. So first thing is, whenever you are given in order and post order, you can construct a tree. Or if you are given in order and pre order, then also you can construct a tree. But if you are given post order and pre order, then it is not possible for you to construct a tree out of it, right? So what you need to do is, this is in order and this is post order. So we know that in post order the traversal is left, right and root. So you can see that the root here is 1. So you can locate the root here in order also. So here in order the root is 1, and 4 8 2 5 are left of 1, so they will be in the left subtree. 6 3 7 is right of 1, so they will be in the right subtree. So what you need to do is, as it is post order, you will start the traversal of the elements from right to left. So first of all you will scan 1, then it will be treated as your root. Then you will scan 3, you will see 3 is right of 1, so you will place it at the right side of the root. So similarly you will scan all the elements from right to left in the post order, 1 3 7 6 2, like this, and you will see its position from the in order, right? So what the elements which are on the left side of the root, that is 1, will be on the left subtree, and the elements which are on the right part of the root will be on the right subtree. In this way you can construct the binary tree. After that you have to find out the pre-order of the tree. So 1 marks, or you can say 1.5 marks for your construction of the tree, and half marks for writing the pre-order, right? And here also in first question, 2 marks for bubble sort, doing all the passes of bubble sort, or it can be 2.5 as well, and 1.5 marks for the discussion of the worst case and insertion sort, right? So these questions are also very very important as far as your competitive exams are concerned. Now coming to third question, convert the following infix to postfix using stack. So this is one of the application of your stack. Here you are given an expression. Generally the expression that you get in exams is very small, but here you have been given a very big expression. The reason why is to judge your skills, whether after some time you will operate it wrongly, right? So basically you need to scan this given expression from left to right, from a till m, and whenever there are operands, that will be placed in the array, and whenever there is operator, that will be placed in the stack. And you have to apply the precedence rule. If a higher operator precedence if a higher operator is coming, that cannot be placed on a lower priority operator in the stack. So there are several rules for that we have already discussed, right? So accordingly apply the rules, and Be careful that you have to solve this expression using stack only. You can also solve this with the direct method also by finding out the priority, like in this expression the highest priority of this bracket. Then out of these two inner brackets, this left side bracket will be solved first, then the second bracket will be solved first. So this is the direct method where you find the precedence of the operators in the expression, and accordingly you solve it, and then in the end the whole expression will be converted into postfix. But this way you don't have to solve the expression, you have to use the stack concept, right? Again, this is also a very important question as far as the application of stack is concerned. Now coming to fourth, and also you know that there is one more application of stack which is very very important, that is parenthesis matching, and the other one is tower of Hanoi. So make sure that you do those two questions as well for your final exam. Fourth, worst case time complexity of binary search is log n based. That we know, right? This is already mentioned in the question, but what you need to do is you have to derive it using binary search procedure mathematically. So simply what you need to do is you will make an array. Let's say you are making an array of 10 elements, right? The array size is 10. So when you apply binary search, you have to apply the principle that the element will be found at the mid location. So you know that the binary search, the elements are arranged in sorted order. So if you want to search an element, it will be found either in the left or in the right. So in the next step, initially the size of the array is n. In the next step, it will be n by 2. Again, in n by 2 also, you will find out the mid, and then also you will find out whether the element will be found in the left side or in the right side. Accordingly, after every step, after calculating the mid, at every step you are moving either in the left or right, and you are dividing the list by half, right? So initially the list size is n, then it will be n by 2, then n by 4, and likewise in the end the number of elements in the array is 1. So this we have already discussed in the class in detail, and I will also upload the solution. There you will get to know how to attempt this question, right? So when you will use this concept, in the end you will find out that the time complexity is this, right? Now coming to the fifth question here, if the number of nodes are 4, draw all the possible binary trees. So there can be any type of binary tree. It can be strict binary tree, complete binary tree, or normal binary trees are there. So but the number of nodes should be 4, right? There can be skewed binary tree, left skewed, right skewed, complete binary tree, strict binary tree, full binary tree. So all those concepts you have to use, and you have to make all possible trees. The number of trees that will be made here will be 14. Now coming to sixth question, discuss the significance of stack in recursion using an example. See, this question is misunderstood by most of the students. What you need to do is you have to simply write a function, which not simply a function but a recursive function, which is calling the function again and again with the help of the recursion, and every call of the function will be placed in the stack, right? So you can use the example of factorial also. That also we have already discussed in class, and I will upload the writing style of attempting all these questions in the next video. So till then, stay tuned. Thank you so much.